Yes, this live. It's a very happy class. I am very happy and touched to be with all of you here. By the way, for those that stream that are not seeing, this classroom actually has 2,000 people. They all showed up to see me teach this class. It's a very important lecture, 2.5, Roots of Polynomials. And thank you all for being here and bringing all this chocolate and donuts and apples. It's amazing. Uh, so we talked before. Yes.
Are you teaching Precalculus?
Yes, but not next semester.
Why not?
What?
Now the question is if I'm teaching Precalculus 2, and the answer to that question is yes, I do teach it, but I'm not teaching it next semester.
Why?
Because I'm teaching Calculus 1, Calculus 2, Calculus 3, differential equations.
Oh my God.
And now what's happening over here is a riot because I'm not teaching. Believe me, you don't want to take that course with me because I will be the same.
That's what
All right.
So who are we going to take then? Someone that's going to...
Everyone.
No.
Oh, this is all live.
Don't tell me everyone, because it's not everyone.
It's not everyone.
This is my second time attempting this class.
And you're not dreading it yet?
I've never
I had an adjunct before.
Okay. Well, I was adjunct at one time.
Well, but you're not anymore.
No.
See how that works?
All right. So welcome back to class. There was a little riot. I guess some emails and letters will be sent in the future, and we'll see how that's gonna go. Let's talk a little bit about roots of polynomials because we're all excited about that, right? Yes. All right.
made my day.
My car died this morning, so look at me. I'm happy.
You should just not teach like Calc1. Just say, goodbye Calc1.
All right. All right, let's go back to... I'll have to edit this video. Hello and welcome back to Precalculus 1, section 2.5, roots of polynomials. This is extremely important section. It ties on everything we did in chapter 2. And you will see a glimpse of it today, but down the line as you take more math courses, that polynomials and finding roots of polynomials is probably one of the nastiest businesses in finding roots, because we have few of these equations that we could work with to find certain roots for certain exponents, and then after certain exponent is just good luck. So I would like to show some of this some of these equations. All right, so what we are going to see now is a page that shows, if it ever opens. Nothing is working today.
You should just come back on next Tuesday and just reassess the class.
I'll bring you chocolate.
I'll bring you money. $50.
Awesome, I got it. All right. So what I'm going to start off with is what is the meaning of a root. So you have your good old x and y coordinate axes, and you have a function of some sort, whether it's polynomial or exponential, logarithmic, trigonometric, doesn't matter what kind of function, is going to cross x-axis. So this point of intersection between the graph and the x-axis is called either a root or x-intercept or a solution or a zero. So these are the four names for the same concept. Wherever the graph crosses the x-axis, you can attach any of these names. Now, if you have good old y equal mx plus b, which is the polynomial linear, right, linear line polynomial, you can quickly find out the x-intercept by simply setting y equal to 0. It was on your previous lab. So to find the x-intercept, which is actually the root and solution, whatever you want to call it, you will solve mx plus b equals to 0, from where x is clearly negative b over m. So anytime when you need to find 0 or a root of linear function, you can just quickly either use the negative b over m if you want to remember that at all. But if you are memorizing the concept, which is x-intercept occurs whenever y is equal to 0, you can quickly set y to 0 and just find that x-intercept fairly quickly. Now, what happens when you go to the next available power, which is squared? You will run into y equals ax squared plus bx plus c. And if you are looking for x-intercept there, you will again set y equal to 0, and you will get ax squared plus bx plus c equals 0, which is known as the quadratic equation. Now, quadratic equation, you might be lucky and be able to factor it, but then you might not be lucky, and then you would have to use quadratic formula to solve it. So x equals to negative b plus minus square root of b squared minus 4ac divided by 2a. So this is what we have for our x-intercepts, also known as roots, also known as zeros, if you have a quadratic polynomial. What's happening with the cubic? Y equals ax cubed plus bx squared plus cx plus d. Well, I'm not going to write this down because you'll see why. But again, there is formula. Just like you have a formula for the linear one and you have a formula for quadratic, there is a formula for cubic. And the formula for cubic looks like this. So you have a cubic equation, and then this is the calculation that you quickly go through, and you get the solution.
What?
Yeah.
I don't even know.
So this over here is where you compute the values for these. So it tends to be a little bit longer than you are used to. Now, for the fourth degree equation, there is also a procedure. It's not a formula anymore, now it's a procedure. And I tried it once. It took me about an hour to get the first number. And after that, good news. For the fifth degree and above, which means 6, 7, 8, 9, and so on, there is a proof, there is a mathematical proof that no procedure or formula can be written down or devised to find roots. So in that case, we are stuck with either numerical methods of finding roots, which is possible. You saw the intermediate value theorem, which is correct, right? You can always use that. But there are others, more interesting techniques in calculus. So what we are going to do today is we are going to look into fifth degree and sixth degree and so on, but we are going to find a much easier method than cranking these long formulas. So are you going to need quadratic formula? The answer is hell yes. You will need negative b plus minus b square root of b squared minus 4ac over 2a. You must know that one. And we are going to use it today and the next day and so on. But we're not going to go and memorize these ones for the third degree and so on. Unless you really want to. In that case, right. So, I will. We are going to start today with first taking a look at the rational zero theorem. So we'll start with the rational zero theorem, and then we are going to see how we can use that to find the candidates for our roots when we have these multiple values. So let's write this. If f of x is an x to the n plus an minus 1 x to the n minus 1 plus dot 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 plus a1 x plus a0 has integer coefficients, and p over q is a rational zero of f, right, f of x, then p is a factor of the constant term a0, and q is a factor of leading coefficient an. So as you are looking into the definition up there for f of x, you should be able to recognize a polynomial, definition for a polynomial. So that an, age x to the n, sorry, is something like, let's say, 3x cubed. And then the next one would be 5x squared. Because you see that n, and then n minus 1, that means 1 power less. And then n minus 2, 2 powers less, and 3, and so on. And it ends with a1x to the first power plus a0. No coffee. So now, this rational zero theorem tells us that if we are able to find p and q, which divide and become and are a zero of a polynomial, then p is the factor of a constant term, and q is the factor of leading coefficient. So now I'm going to write it in red over here. Possible rational zeros are given by factors of the constant term divided by the factors of leading coefficient. So this is what we have as our method, actually, to find this. So let's take a look at an example. F of x equals to negative x to the fourth plus 3x squared plus 4. This one is a constant term, and this one over here is the leading term. So, if I'm looking for PERS, what's PERS? Possible rational zeros, yes. Known as PERS. Yeah, cat PERS, yeah, okay, fine. So, possible rational zeros would be all factors of 4, which are plus minus 1, plus minus 2, and plus minus 4. That means all of the numbers that would divide 4. 1 divides 4, 2 divides 4, 4 divides 4. 3 does not divide 4, therefore it's skipped. Divided by possible factors of the leading coefficient, and that leading coefficient is negative 1, so plus minus 1 is the entire list for that. So now, if you take into consideration all of the combinations, you will get plus minus 1, plus minus 2, plus minus 4. And that is the list. So this is the list. This list has 6 numbers. And one of these could possibly be a root. Now, what's the most number of these that could be roots? The most number. 4. Why 4? Because we can have at most 4, for this problem, we can have at most 4 solutions, right? 4 roots, because it's to the 4th. Remember that the leading term test tells you what? How many roots, which is the exponent, and then even and odd, orientation, right, for end behavior, and then orientation, positive A, negative A, right? So you have 3 aspects to that root, to that leading term. Cool. Now observe one more thing. Factors of leading term, of leading coefficient, are in denominator. Can that ever be 0? Why not? You can't divide by 0, but isn't that correct that if the leading coefficient is 0, that would kill your term, right? It will completely kill that term. So you see, you can't have 0 here because it will kill that term and it will not be the same polynomial, and you can't have 0 here because you can divide by it. See how mathematics just fits every time? There's no way that you can, with one concept, cheat another. It's all related. We good? All right. I was about to use the words "you guys" and then "awfully" at the same sentence, and I decided no. No, when it's taken out of context, it does sound bad. I just wanted to say you're awfully quiet, but then, you know.
Let's get interactive video.
4:30.
Yeah. Where is admission?
I'm sorry?
Where is admission?
Admissions?
Yeah.
The office over there.
Over where?
Yeah, in Huntington building. All right, we'll figure out later. You had enough? All right, so next example. Run, she's getting away. Next example. f of x is equal to 15x cubed plus 14x squared minus 3x minus 2. Let's take a look at pairs. What are all possible factors of 2? Plus and minus 1, plus and minus 2. Awesome. What are all possible factors of 15, which goes in denominator?
Plus or minus 1, plus or minus 3, plus or minus 5.
Awesome. And plus and minus 15. So you are looking for all numbers smaller than the number in question that can be divided into. So for 2, it's 1 and 2. For 15, it's 1, 3, 5, 15. How many numbers is this that we have to check? Well, you have to list all combinations through division. So you are going to get 1 and 1 in division, and then 1/3, so 1/3, and then 1/5, and then 1/15. And then you repeat everything with 2's. Plus 2, plus 2/3, and then plus 2/5, plus minus 2/5, and finally plus minus 2/15. Which is 16 numbers.
That's it.
Why, disappointed?
Complete, right?
This list is complete.
Okay.
So this is the first stage in what you will need to do. Yes, you will need to be able to find the list of possible rational zeros. That's the pairs over there. Possible rational zeros. Now, once you have that list, you're going to start taking these numbers one by one and checking which one of these is going to give you zero remainder. Whichever one gives you zero remainder is a root. And then you do synthetic division by it. Rinse and repeat.
Wait, what did you say again? Sorry.
Yeah. So now that we have a list, we are going to start taking, out of these 16 numbers, we are going to start taking them one by one and checking for zero remainder. Once you check, you want a zero remainder. Once you have a zero remainder, that means that that particular number is a root whose linear term is the factor. And then you go from there. So let's do an example that will have all of that. So a little bit less spicy example. I mean medium spice dish. X cubed plus 8x squared plus 11x minus 20 and we are immediately going to find a list of possible rational zeros. So factors of 20, oh, it's going to be a lot. 1, 2, 4, 5, 10, and 20. Awesome. Divided by plus minus 1 because our front coefficient is 1. That's it. So now we have the list of possible rational zeros. What we do is we take these numbers one by one and start checking. Now you have two ways. You can check it through synthetic division or you can check it through the remainder theorem, right, where you plug in a number in. If you get 0, we're good to go. So let's plug in 1. How much is f of 1? F of 1 is going to be 1 plus 8 plus 11 minus 20. Oh, are you feeling lucky today? We got it. On the first try. We know that x equals 1 is a root. That means that I can do synthetic division with 1. And that will reduce our polynomial down to a quadratic. So drop 1. 1 times 1 is 1. Becomes a 9. Becomes a 9. Becomes a 20. Becomes a 20. Becomes a 0. So now the polynomial is x squared plus 9x plus 20 equal to 0. So we found one root already. And now we're left with the quadratic. Remember, if you can factor it and you know how to factor, that's going to be much better and faster than cranking the quadratic formula. We know that 4 times 5 is 20 and 4 plus 5 is 9. So this factors over x plus 4, x plus 5. Which means that the other two numbers they are looking for are negative 4 and negative 5. Also roots. So what is the factored form? X minus 1, x plus 4, x plus 5. That's the answer. We were able to factor this polynomial. Cool. Anyone? After the first example, 738 people left. And one is not doing too well at the moment.
Wait, are we getting another example? That'd be good.
This is it for today. So we
Yeah?
Really? Look at different difficult examples because when I do homework, I get like really hard and questions. I went into the class, it's always easy, I don't understand.
and you can sense how happy they are. Asking for extra examples. All right, next example. X to the fourth minus 2x cubed minus 5x squared plus 8x plus 4 equal to 0. So find all possible rational zeros first. Keep testing one by one until you run into a zero remainder.
I set this up right once after I found that 2 is in the root? So here.
You found a 0?
1, 0, 2,
Awesome.
3.
Nice. Nice.
That's right.
So now keep recycling through the list. Try the same number again and others. Whatever you tried and didn't work so far will not work. So.
Okay. But do you want me to like factor like how we did up here? Like,
well, this is a cubic, so you can't.
Okay.
So you have to keep doing the method. I just want to give another 5 minutes and I'll do it, but
okay.
No, not 5. Let's take a look at this problem together. We have possible rational zeros at plus minus 1, plus minus 2, plus minus 4 divided by plus minus 1. So factors of the coefficient term divided by the factors of the leading coefficient, in this case 1. I'm sorry? There is no 5. The numbers are 1 and 4 that are in the game. Here is number 1, which goes in the denominator, and number 4 that goes in the numerator. Nothing else matters. So now we are ending up with a list plus minus 1, plus minus 2, plus minus 4. These are 6 numbers which are possibly roots of this polynomial. Now, since we have the 4th degree, at most 4 of these could work, but you know what? Either 2 could work or none, or all 4.
Why would only 2 work?
Because 2 could be complex. With the complex numbers, like 1 plus I, 1 minus I. Well, we'll get those problems eventually, and you will be happy. There will be 4 answers, but no, we will be able with the quadratic formula, because that will give you negative under the square root, and you would enjoy that with a smile. It was a fake smile, but that's okay. That's genuine. So let's check f of 1. So as I plug in number 1, I get 1 minus 2 minus 5 plus 8 plus 4. And we don't get 0. I'm not even going to compute. Then we try negative 1. That's going to be 1 plus 2 minus 5 minus 8 plus 4. That's not going to work. F of 2. So 2 to the 4th is 16 minus 16 minus 20 plus 16 plus 4, there it is. There's 0. So we know that x equals 2 is a root. I immediately do synthetic division. So 2, 1, negative 2, negative 5, 8, and the 4. And then I drop down 1, then it's 2, which becomes a 0, 0, negative 5. And then 2 times 5 is negative 10, gives me negative 2, gives me negative 4, and 0. Obviously, we knew that it had to be 0 because the remainder has to be 0 in order for it to be a factor. And all I need to do now is to write out this. And I will write 0x squared just as a placeholder so we know. So there it is. Our 4th degree polynomial became a 3rd degree polynomial, and now we are starting procedure from scratch. Now, we don't need a new list. We use the same list. And in a matter of fact, all of the numbers that didn't work before will still not work, so we can just resume from the number that worked last time. Now, keep in mind multiplicity 2, multiplicity 3. So you have to check number 2 again in the new polynomial. You have to check number 2 again because it might have 2 or all 4 roots to be 2. So you have to check 2 again, and then if that doesn't work, continue with the list wherever you left off, which means negative 2 and then positive 4, negative 4. We just need to find one more, because when we find one more, the next pair of these will be, we can utilize the quadratic formula if we can factor. So I'm going to now start with, again, f of 2, which is 8 minus 10 minus 2. Right? Doesn't work. Now we're going to try negative 2, and we're going to get negative 8 plus 10 minus 2, and that one works. So we have our polynomial 1, 0, negative 5, negative 2, and we are going to use negative 2 now. So that is 1, negative 2, negative 2, positive 4, negative 1, positive 2, 0. Awesome. So the polynomial that we are getting is now x squared minus 2x minus 1. And this is the part where I really have to stop and mention one thing. Please understand this. We started with the 4th degree polynomial. And once we found the first 0, which was 2, we immediately divided the original polynomial by that term, and we arrived at the 3rd degree polynomial. Now, I have a 3rd degree polynomial. 3rd degree polynomial, right here, is like starting a new problem. Forget that you had your 4th degrees for now. You have a new polynomial to work with. Luckily, you still use the old list for it. So when you find a new root, like we found here, that x equals negative 2 is a root, you don't go back to 4th and divide. No, you divide your 3rd degree, your latest polynomial, with that one. And then you are getting your quadratic. Because, guys, if you go back to original one and divide it by the negative 2 root, you are going to get another 3rd degree polynomial. You will never be able then to go back down to the quadratic one and use the quadratic formula. This one doesn't factor, so we use the quadratic formula, negative b, so that's going to be positive 2, plus minus, square root of negative 2 squared is 4 minus 4ac. Divided by 2. I don't like this. It's plus, right? Yeah. So you're getting this, right? Is that true? Now square root of 8 is 2 root 2. Give me 1 second. And then when you divide these 2's, you get your last 2 roots as 1 plus minus root 2. Yes? No, because remember, all of the factors are for the entire 4-degree polynomial. So if -1 didn't work in the first run, it will never work. So that's the reason. But what you need to train yourself, and this is what I see year to year as an issue on the exam, is that you don't try the same number that worked before. You could have multiplicity 2, multiplicity 3, right? So you could have 3 roots to be 2, and then the fourth one to be, I don't know, -1, right? So you have to go, whenever you find your first root, you have to check that same number once you reduce it down to the next polynomial down, degree down, you have to recheck that number again because you might have multiplicity 2. And if you get that it's root again, yes, it is root again. In that case, it will be multiplicity 2. And then you reduce it down to the next polynomial. You have to check it again because it could have been multiplicity 3, right? You can come up with, 4th-degree polynomial where all 4 roots are 2. That's okay. You have to keep checking the same root until it stops working. Yes?
Wait, how did you know that that's a root?
Because it gave me 0 on the factor theorem from last class.
Oh, okay.
Right?
Yeah.
When the remainder is 0 after division, the linear term is a factor, and then its constant there is a root. So now, guys, what is the answer? We wanted to factor this. What is the answer? The answer is, the first root is what? X minus 2, x plus 2. Okay. So here's the answer. X minus 2, x plus 2, x minus 1 minus root 2, and x minus 1 plus root 2. These are our answers for this factorization. That's the factorization. And the roots are 2, -2, 1 plus root 2, 1 minus root 2. They're all there. Cool? Yeah, that's the spirit. Let's do another one, because you can. Have you ever complained in algebra that the problems are too long when they have 5 steps?
Yeah.
Yeah, you see what happens now? You know what I'm going to do? How about we go to Calc 2, take a look at the last class? I know, it's awesome.
Like 2 pages for one problem.
Look at that. It's awesome, right? Don't you love it?
This is Calc 2.
Yeah, look at that. The engineers take this class.
Do you have a Calc 1 problem up there that you can show?
Yeah, they're not better, brother.
What I'm looking into.
Looking forward to it. All right, next one. 3x to the 4th minus 11x cubed minus x squared plus 19x plus 6.
So is this the type of homework we have to look forward to when you put it up?
I'm sorry?
Are these the type of problems we're going to see on the homework when it gets put up?
This is taken from, as you can see from your textbook, from the homework page. This problem that I just read is exactly problem 47. And the previous problem is also from the homework page. I don't know which one now, but so this is what you're expecting on the homework, and this is exactly the question. I'm usually on the exam. I usually put fourth degree. So you might as well star this problem as the exact example of the exam question, and probably your final exam question.
But you don't make our final.
Yeah, I don't, but they should have something similar. I hope. So this is 47, and this would be the perfect example of the question that you might see. So factor completely, which means find all factors, find all roots. Mm-hmm.
Okay, nobody takes this yesterday, but how'd you get this cover? This one.
So
These ones.
you multiply back, right? So
Like how? One.
numbers.
Okay.
So you drop 1 down.
Yeah.
2 times 1 is 2. Add. 2 times 0 is 0. Add. 2 times -5, -10. Add.
Add or multiply?
Add down. You multiply this by this times, and you write it here.
Okay.
And then you add down.
Okay. So
And then
from
you
this
multiply.
number.
0 times 2 is 0. Add down.
Oh, whatever. I'll multiply this one and I get this answer and I.
You multiply these into that.
Okay, 2. So I get 2.
And you write it here.
Okay, and I add this here.
Yes. So now 0 times 2 is
0.
yes. Add.
0 multiply.
No.
Do I have to so it's -5.
-5
-5.
times 2
Oh,
is
okay.
-10.
Okay.
So this is how I go. Multiply, add.
Yeah, okay. Okay, thank you. Yeah.
It's a pattern. You gotta memorize.
Yesterday I was understanding, I was like, this morning I was like,
Yeah, because it's not something that is.
I can do synthetic division for everything instead of filling in for x, right? Or no?
Yeah.
Okay. And then, so we had 3 for that, got to 0, and just keep going through them all, or?
Someone actually found -1. You just keep.
Oh, really?
Yeah, -1 apparently worked. I don't know. I'm gonna do it now.
I might have.
Okay, let's take a look. Did you get all 4? Did? Awesome. Let's take a look at this together. So we are going to find the possible rational zeros first. We have +-1, +-2, +-3, +-6 as factors of the constant term. And we have +-1, +-3 as factors of the leading term. So now we do all of the combinations, which means 1 from here divides into all 4, and then 3 divides into all 4. And we don't have to put the repeats. So 1 divided by 1 is +-1, 2 divided by 1 is +-2, 3 divided by 1 is +-3, and 6 divided by 1 is +-6. And then we have division by 3, which would be +-1/3, +-2/3, and then 3 over 3 is 1. We already have that. And we also have 6 divided by 3 is 2. We already have that as well, so we don't need to write those. We obtained the list of 12 numbers, right? We have 6 plus-minus numbers, so that's 12 numbers altogether that need to be tested using our remainder theorem to find roots. So we'll first check f of 1. F of 1 says 3 minus 11 minus 1 plus 19 plus 6. And I immediately say that's not going to be 0 because I see 19 and 6. 19 and 6 are 25, and then 3 is 28, and 11 and 1 cannot counter positive 28, so it can't work. Let's try -1. For -1, I have 3 plus 11 minus 1 minus 19, and then plus 6. So, yeah, that works. It's a 0 because you have a 14 and then 13 and then this is -13, so yeah, that worked. So -1 is a root. You can say x equals -1. So now you immediately do synthetic division with -1. We have 3, -11, -1, 19, and 6. And now with the synthetic division, we drop down 3 times -1 is -3, which is -14 when we add. That's going to be +14, which gives us 13 when we add. That's -13, which is going to give us 6, and then -6 for 0, which is what we expected. So now what you have is 3x cubed minus 14x squared plus 13x and then plus 6 equals to 0. The next part is to again check -1 because you might have multiplicity 2 on that root. So we check f of -1 again, but this time we are using the new polynomial, the third degree. So we have 3 minus, no, that's a -3, minus 14 plus 13 plus 6. And that's 0 again, right? Because these two, oh no, it's not 0. No, these two add to -17 and these are to 19. So it's not 0. So we go with 2 now. 3 times 8 is 24, minus 14 times 4 is a lot, 64. No, 56. No, 56, that's what I said. Please pay attention. Plus 13 times 2 is 26, and then plus 6. 24. This works. This works. So we have x equals 2 is a root. Since x equals 2 is a root, we immediately do synthetic division, starting with our new polynomial, because we want to push forward.
Wait, so f minus 1 is not a root?
No, it was before, but in the new polynomial, reduced polynomial, it's no longer. So that's a 6, which gives us -8, which gives us -16, which gives us -3, which gives us -6, and it's 0. And there we go. So our new polynomial is 3x squared minus 8x minus 3 equal to 0. And for that one, we can crank quadratic formula. Quadratic formula says something. Quadratic formula says -b plus minus square root of 64 minus and minus gives me plus 36, that's what I said, divided by 6. So that's 100, which is a 10, so 8 plus minus 10 divided by 6, which gives us two answers. 8 plus 10 is 18, divided by 6 is, x equals 3 is a root, and we have -2 over 6, which is -1/3. Exactly. So now we have 3 roots.
We have 4.
That's what I meant. -1, 2, 3, -1/3. And then we have the factors. X plus 1, x minus 2, x minus 3, and x plus 1/3.
Why do you put this on?
That's an excellent question. Why do I switch the signs? So when we have a factor is x minus c, where the root is x equal to c. There are always two opposite signs because, as you can see, to find the factor, you always set things equal to 0. So x minus c equal to 0 solves for x equals to c. So in synthetic division, in the cubby, you will put the root, but in this one, you will have the opposite sign. They're always opposite signs. What goes in a cubby, which is the root, against what goes in a factor. Because, right, that equal to 0 part when you solve. You want another one?
No.
That was
Mixture views.
I know. Well, I'm just going to move on with the next concept then from the same lecture. The next part is, and I'm going to write it in red, some roots are complex, meaning a plus bi. What was that? So some roots could be complex. Complex roots always come as a conjugate pair. So you always have a conjugate pair. You can never have one complex root. You always have to have a plus bi, a minus bi as a pair. They always travel in pairs. So complex roots always come in pairs, and that is a plus bi and a minus bi. So now, if you have a root which is 1 minus I, you also must have a root 1 plus I. You cannot escape that. Cannot escape that. It's always the case. So I would like to find the one that has complex roots. All right. This is how your homework page looks like in a textbook. So a whole bunch of these. I read 3 from that list. You're going to have a whole bunch more. No, just stare at it until I figure out the problem.
I can't even see it.
Let me see if I can read it. Here, let's pretend we're at the eye doctor.
I can't even see.
3x to the 4th minus 11x to the 3rd minus 3x squared minus 6x plus 8 equals 0.
3x
Boom!
4 minus 11x to the third minus 6x.
So I could create a problem.
C24 is x to the 4th minus 2x cubed minus 08. Now, yes. X to the 4th minus 2x cubed minus 16x minus 16. Right? It's just like I need to do something.
No.
Tell me another one to read. Tell me another one to read. 29. Where is it? It's pointing out the page. I'm gonna pick another one. 9. X equals x cubed plus x squared minus 4x minus 1.
All right. Here it is. F of x is equal to x cubed minus x squared minus 7x plus 15.
Repeat that again. I got x cubed.
X cubed minus x squared minus 7x plus 15.
So what are we doing?
Same stuff.
Oh, goddamn. So like,
Yes. Oh, it's written twice. So do the same as you have been doing so far. We're going to check and see what kind of solutions you get.
I'm so hot right now. We need a fan. I'm gonna bring out portable.
How are you hot?
My face just got really hot. I don't know why.
Monday.
Well, like enough people just don't go over and put it into a trunk, like someone else can make it. Either way, we're good. Well, yeah, their kids are friends. It's weird.
All right. What is it?
It's like, don't even know what's going on. That's fucking stupid.
Are you done?
I can't find one.
Yeah, it turned into college.
Political debate? All right. I guess math is done for the day. But we still have two concepts, guys. Cool.
-3. We'll get there. It's capital G, this is the constant, times mass 1, mass 2, mass 3. Distance from the
you know the method, yeah. You can find the method. Because it's not that much. In astronomical units, you get effectively no difference from million per million because they are slightly, it's a 2%. And it's called basic physics.
Well, I started rewriting it, or you do now. Yes, definitely. Well, I started rewriting it to find OCD and my level of OCD. Well, I'm writing it. I stopped though. I got distracted. No, I want to. I know. I want to show him. So start from -3. 1 plus I.
Let's take a look at this problem together. We have possible rational zeros at +1, ±3, ±5, ±15, divided by ±1, so we only have these 8 numbers on the list. So we check f of 1, and we see it doesn't work. You check f of -1, you see it doesn't work. Then check f of 3, and that doesn't work either. And check f of -3, and that works. -3? Anyone? -3 does work, right? So now we immediately work on the synthetic division. 1, -1, -7, +15, divided by, we drop down 1, -3 is -4, that's going to be +12, which gives me +5, gives -15, and there is 0. So now we reduce this to x squared minus 4x plus 5. That's the new polynomial. Since it's quadratic, we can unleash quadratic formula. And a quadratic formula says -b plus minus square root of 16 minus 4ac. And do you see what's happening?
Yes.
You are getting negative number under the square root. What does that mean?
It's going to be an I.
It's going to be an I.
Aye, Captain.
So, observe why you must have complex conjugates at all times. Quadratic formula will always give you plus and minus answer, and they always work because that's the real part, that's the imaginary part. You can't combine them ever. That's why you will always have the complex conjugate pair as the solution pair. So now, what do we have? We have 3 roots because it was cubic, right? We have roots at x equals -3, 2 plus I, and 2 minus I. And the factors, x plus 3, x minus 2 minus I, and x minus 2 plus I. Remember to change the signs between the roots and factors. So this is one of the exam questions. Whether it's going to have roots complex or not, we'll see. You'll see when you solve it, right? But you see that the procedure is not different at all if you have complex roots or real roots. It's the same procedure. And now we have 4 minutes left and then another 5 after that.
Give us a break.
There's no break. There's going to be a break for Thanksgiving. You won't be here on that Thursday.
Wait, what?
Thursday, Thanksgiving Thursday. We're going to waste that day unless you don't want to waste the day and we schedule something. But
Are we gonna do anything important on that Tuesday before
what happened? All right, the last thing for today, and then we'll talk about, guys. Shh, shh, shh. No.
I don't have the time or energy to do it.
All right. This is another part that is very frequent on the homework, and it's usually there for exams. And that is how to obtain polynomial if you have roots given. So, I give you roots, and you are supposed to figure out the polynomial which those roots provide. So let's see. Let's say, maybe I can pick up something from the textbook. There we go. So this is the information. X equals to -5. X equals to 4 plus 3i. And additional piece of information is that f of 2 is 91. Which polynomial fits this description?
What is that after the plus?
3i. Which polynomial fits this description? Does anyone have any idea of what we should do? Yes, Fred? Oh, no, we are supposed to obtain a polynomial. How do we find polynomial from this information?
Oh.
Yes.
So it would be x plus 5 in parentheses.
Nice.
And then it would be x, is it -4 minus 3i? So it doesn't have to have both.
Nice.
So it would be x minus 4 plus 3i as well.
Great. So, when you see a complex root, it is your responsibility to know that the complex conjugate also has to be on that list. And once you have that, you are able to change those into a factor, right? Each one of these. And all you need to do now is FOIL. Multiply this out. Now you multiply first multiply the complex ones, and then deal with the x plus 5.
How do you get rid of the I though? Because that won't show up as R.
Once you FOIL everything, it will be clear. So x times x is x squared minus 4x plus 12 xi, and then minus 4x plus 16 minus 12i minus 3ix plus 12i, and then minus 9i squared. Observe that each one that had I in it will cancel because 12xi and negative 12xi somewhere. Oh, I forgot the x, right? All right. And then we have, no, I didn't calculate. Oh, I got to do it again.
You didn't do it right.
That's okay.
Write all that down for notes.
Let's start from scratch. So x into x, x into 4, x into this one. So that should be plus 3xi minus 4x plus 16 minus 12i minus 3xi plus 12i minus 9i squared. Awesome. So now we cancel all the ones that are this. There we go. And these ones. And as you can see, this is plus 9 because I squared is negative 1. Negative 9 times negative 1 is positive 9. So now it's x plus 5.
Oh, you missed the 4. Nope, just kidding.
No, it's all good. X squared minus 8x plus 25. There we go. And now we FOIL again. So that's going to be x cubed minus 8x squared plus 25x plus 5x squared minus 40x and plus 125. Combine like terms, put everything in descending order. We're almost done there. It's negative x cubed minus 3x squared, and then minus 15x and plus 125. No, because now if you want to go through that point, and this is the key which most of the people don't know for the exam because everyone wants to leave by this time of the lecture, is that you are supposed to multiply the entire polynomial with a, because that will adjust the front coefficient of x cubed. And now you have that is equal to your f of x. So this is where that f of 2 equals 91 comes in. You will write a x cubed minus 3x squared minus 15x plus 125 is equal to f of x, and this is where you plug the value. This is 2, so 2 cubed minus 3 times 2 squared minus 15 times 2 plus 125, all of that times a, supposed to be 91.
Why do you multiply by a?
Yeah, I don't understand.
I will explain. So let me just compute this. So it's 8 minus 12 minus 30 plus 125 equals to 91. So is this 91 again?
Yeah.
125 minus this is 95, and 8 is 3. Yeah, it's 91. Awesome.
You didn't believe me.
A is equal to 1. So the polynomial we are looking for is just x cubed minus 3x squared minus 15x plus 125. Awesome.
Wait, well, I don't understand the a part.
Okay, well now I'm going to explain the a part if you give me a chance. 30 seconds left.
Go.
So what is the a part doing? A part is the one which would stretch or shrink the function vertically. So let's say you have a cubic function that looks like this, and you want that function to keep the same min, max, and the point here, but you want that function to go through this point. By multiplying that function by a, it will vertically stretch it so it goes through the same points, but it will hit that point as well. And that is achieved by simply taking your polynomial and multiplying it by whatever value a needs to be, so it bends enough to go through the point that it's given to us. So once we multiplied all of the factors and came up with a polynomial, we are multiplying that by that unknown a that we need to find, making sure that the polynomial goes through this point, which is the reason why we plug 2 and 91 in the equation. And the rest, calculate a little bit more, and we found that a is equal to 1. But sometimes it's 2, sometimes it's 5, sometimes a quarter. So it could be any value there.
So then you just put 2 in front of x.
It's in front of h1.
I don't understand.
Yeah. Are you popular?
I'm coming that way.
I'll give
Yeah.
quick question for you. So one of the ones we were doing before this problem here, I got confused when 3 was a root, -1 was a root. But then when we used 2 as a root, we used what we got from -1. I don't understand.
I felt like I was flying
why
for a
it was
good
brought
10
over
minutes.
to use for 2.
It's
Like,
You keep reducing. You keep reducing. So you go from the 3rd degree down to the 2nd degree, or from the 4th to the 3rd to the 2nd. You always want to knock it off down.
okay. Oh, okay. That makes sense. Then.
Yes.
Okay.
You keep dividing.
Gotcha.